Hello everyone. I'm honored to be able to report our research results here on the use of graph modeling in crowdsourced data to detect fake reviewers. My title is Crowdturfing Detection in Online Review System, a graph-based modeling. Our team consists of 3 people. Feng, Qilong, Zhang, and Kuang come from the School of Computer Science and Engineering, Central South University in China. I am the reporter, Zhang. We proposed a crowd detect framework and verified the effectiveness of the model with experiments. The contents are as follows: contains background, related work, crowd detect framework, experiments, and conclusion. Then I will first introduce the background of the research. Crowdturfing is a spam worker from crowdsourcing platforms like AMT or Crowdflower. They post fake comments on e-commerce platforms or review sites for the purpose of obtaining remuneration. Unlike the original fakers, Crowdturfing can perform tasks alone, so it lacks concentrated behavior features and is more difficult to be detected. The fakers can be divided into the following 3 categories, according to the different motivations. Camouflage's purpose is to add ads in the comments without being recognized, for the reason that they add links by adding special symbols. Spammer increases the popularity of products by sending some irrelevant content or advertisement. Crowdturfing can get reward for completing a comment task, which is published on the crowdsourcing platforms. Although crowdturfing cannot be easily identified, the researchers found that these people still have some commonalities in the content of the comments and the behavior of the reviewers. Therefore, the existing work can be divided into the following categories. Content-based detection method. Pay more attention to the indicative features on the content. The n-gram and part-of-speech features of the review text is concerned, and natural language processing methods are used to detect the fake reviewers. Behavior-based detection method focus on the characteristic of fakers other than comments content, such as timing bursts and the similarity of network structure. Graph-based detection methods is more concerned the interrelationships among objects in real-world problems, which can identify fake reviewer nodes through matrix calculation or graph embedding. Based on the existing research, we propose a method based on graph modeling. Considering that fakers will review similar products, we build a relationship diagram between reviewers and products which can reflect the impact of products' attributes on reviewers. At the same time, we assume that people who have reviewed the same products are related, and therefore they are neighbors in the isomorphism graph. Then a co-reviewer graph containing all reviewers and their relationships is obtained. After modeling, we propose an aggregation model which obtains the representation of the reviewer from two dimensions, review space and society space. Finally, by concatenation these two vectors, the final prediction result is obtained through a multilayer perceptron. This is the overall structure of the crowd detect. Three parts were contained in this framework: review aggregation, society aggregation, and label prediction. Later, I will introduce the design of each part in detail. For the eye reviewer, multiple products can be reviewed. Each product space aggregates reviewers, products, and product review vectors. U represents the embedding of the user. V can be understood as product review embedding, and E is product embedding. Then the attention mechanism is used to aggregate them from multiply product space. Alpha is the attention coefficient, which aggregated the X from different product space. The vector in the society space is obtained by aggregating the neighbors of the current reviewer. Beta is the attention coefficient used here. The representation of neighbors is obtained according to the method of aggregation in the review space in the previous step. Therefore, the value behind B here is the HR of neighbors. In label prediction, the vectors containing the two features are merged. HI represents the merged 86-dimensional vector. Then we will get a two-dimensional output. When it is input into a multilayer perceptron, the two-dimensional values represents the probability of the reviewer being judged as a faker and a normal person, which is the final prediction results, where L represents the number of hidden layers of the multilayer perceptron. In reality, the number of normal reviewers is far greater than the number of fake reviewers. In order to deal with the sample imbalance problem from the algorithm level, we adapt the cost-sensitive learning method to elevate the impact of class imbalance. Since the number of positive samples is small, the weight of positive samples should be relatively increased. Alpha is the shared weight of the total loss that controls the positive and negative samples, and gamma is the adjustable focus parameter. As gamma increases, the influence of the modulation factor also increases. In other words, the modulation factor reduces the loss contribution in the simple example and expands the range of low loss in the example. After proposing the theoretical method, we use a real dataset from the Amazon platform for verification. The dataset comes from Yao's research. He collected more than 110,000 high-quality online review data on Amazon from different categories and different reviewers. The reviewers with fake tags are all from the text posted by the crowdsourcing platform. And we divided the dataset into the training set, the validation set, and the test set. Firstly, we verify the impact of changes in the parameters of the focal length. We fixed other influencing factors and modified gamma value to obtain the experiment results shown in table. With the change of the gamma, the recall increase. When the value of gamma is 0.75, the comprehensive index of the model is relatively high. This experiment is to verify the effectiveness of the two aggregator models. Performance evaluation and receiver operating characteristic curve is shown there. Through the ablation study, we found the combined effect of the two aggregators is the best in terms of recall, precision, F1, accuracy, and area under curve value, which is better than one aggregator. This is because the two dimensions of review features are concerned comprehensively and richer information is integrated. It confirms that the model integrating the features of the reviewer is effective. The last experiment aims to verify the effectiveness of different detection strategies. There are logistic regression, decision tree, random forest, deep work, FDGARs, and crowd detect respectively. It can be seen that machine learning method has reached a high accuracy, while the rate of recall is relatively low. When the method of graph embedding is adapted, the classification effect has been significantly improved. Crowd detected achieved better classification results than other strategy, no matter what. In this paper, we studied a method for detecting fake reviewers from crowdsourcing. Considering the existing graph-based method that have not achieved significant results, an attention-based strategy was used to integrate the representation of the review space and the society space. So, our work can be summarized that, firstly, an attention-based strategy was proposed to integrate the representation of the review space and the society space. Besides, a cost-sensitive method was applied to optimize the loss function of the detection model, considering the imbalance of reviewer classes in real-world scenarios. And we also verified our model on a real Amazon dataset and proved the feasibility and effectiveness by comparing other methods. At last, in the future, the information of review groups and product cluster can be used to further expand the detection methods of crowdturfing. On the one hand, the model could be improved with new scenarios. On the other hand, the problem of data collection should be solved. The above is my share, and thanks for your attention.